Do you weigh the same in outer space? Do you float on the moon? This video is about weight and mass and the difference between them, and it will show you how to calculate one from the other. Around 500 years ago, a physicist named Galileo was said to have dropped 2 cannonballs from the top of the Leaning Tower of Pisa. The common idea at the time was that the heavier ball would hit the ground first. In fact, both the balls hit the ground at the same time. This shows that the rate of an object's fall doesn't depend on its mass. It shows that all objects near to Earth's surface experience the same acceleration, and we call that acceleration gravitational acceleration, and we give it the letter G. We then measured it, and it's a nice round number. It's 10. It's 10 meters per second squared. Or we say it's 10 newtons per kilogram. The next chapter in the story came when a certain apple fell on a certain Sir Isaac Newton's head. Sir Isaac Newton gave us his second law, which relates force, mass and acceleration. A force is a mass times acceleration. If we apply this to the phenomenon of gravity, we rename the terms weight, mass and gravitational acceleration. We get the equation W equals m times g. But hopefully you can see that's just the same equation. The weight is the gravitational force downwards. The mass is the amount of physical stuff there is in the object, the amount of matter, and is measured in kilograms. Then G is the gravitational field strength. You may be expected to use this equation, and you do need to remember that gravitational field strength here on Earth is 10 newtons per kilogram. Let's apply this to the apple. The mass of the apple is 100 grams. We need to convert that to kilograms before we use the equation. There are 1,000 grams in a kilogram, so the mass of the apple is 0.1 kilograms. So we write 0.1 where the m is in the equation, 0.1 kilograms, the mass. And we write out the rest of the equation, remembering that G is 10. So 0.1 times 10 is 1. The apple weighs 1 newton. It creates 1 newton of force downwards here on Earth. So here are some problems for you to have a go with. These are nice ones for practicing your calculation skills. Remember, do calculations step by step. First, identify what information you have. What data do you have and what does it mean? Then, select your equation and rearrange if necessary. Third, input your numbers, input your data, and lastly, calculate. Always round your answer and make sure you put the unit on the end. Pause the video here and have a go, and then I'll reveal the answers. Okay, here they are. These are the answers. Check you're working there. I hope this video helped. Follow the link now to watch David Scott recreate Galileo's experiment on the moon with a hammer and a feather. And there's a reason why this wouldn't quite work here on Earth, and I'm sure you can work out why. Thanks a lot for watching.